This is the Chapter 8 Part 9 video. In this video we're going to talk about proton transfer in multi-step mechanisms. In the last video we actually saw an example of a proton transfer in a multi-step mechanism. So we had basic conditions and we deprotonated the alcohol to make it a better nucleophile so it could then do our SN2 reaction. Let's look at some more examples of this proton transfer happening in our reactions. So in this example, we're going to look at an acidic example. So we're using sulfuric acid, very strong acid, and we're also using HBr, another strong acid. In this case, our starting material is going to be an alcohol. Now, alcohol by itself is not a good leaving group, but in acidic conditions, it can become protonated and fall off as water, which is a good leaving group. So let's look at how this mechanism happens. The first step is going to be a proton transfer. We're going to protonate with HBr. You can also protonate with sulfuric acid if you want to. It doesn't really matter. Both of them are going to provide a nice source of H+. So now we have our protonated alcohol. Remember I said that an alcohol by itself is not a good leaving group, especially in acidic conditions. But now that we've protonated it, it can do a heterolytic cleavage, so this is heterolysis, and it falls off as water, which is a good leaving group. The resulting carbocation can then coordinate with the Br-. So here's our electron rich, going to our electron poor, and forming the product. So again, this is yet another example of a proton transfer in a multi-step mechanism. In our last example here, we're going to look at some intramolecular examples. So in this case here, you can see that we have a nucleophile attacking epoxide. So this is an SN2 reaction where the molecule's going to open itself up. And so the question here is whether the proton transfer occurs intramolecularly or from the solvent. And you'll see that we have an O-, so this is going to have to get protonated after our SN2 reaction. And when our amine attacked, it left a positive charge, which also must be either removed somehow. So the question is what does it happen intramolecularly with our molecule or intermolecularly via the solvent? So let's look at how this happens. It's more likely when you have a small molecule like this that the deprotonated alcohol is going to get protonated by the solvent floating around in solution, and the protonated amine here is going to get deprotonated by some hydroxide that was then formed. So this is kind of two proton transfers that happen that are mediated by the solvent. If you were to have a larger substrate, for example, then you could potentially have it happening in an intramolecular fashion. Let me show you what I mean here. So if we had something that was much larger, let's see, I'm going to make our nitrogen here and give it a positive charge. So in this case, what I've done is I've drawn a larger ring system. So notice that we've got 1, 2, 3 carbons separating the O- and the NH+. And so if you have enough carbons between them and you can form a nice ring here, then it potentially could happen intramolecularly. So this is an intramolecular proton transfer. The O- is pulling off the hydrogen, and the electrons here are going to go to that nitrogen there. And this would also be another way to do a proton transfer. If you have a smaller molecule, then it's better to show the solvent, for example in this case water, mediating the proton transfer.